All right, let's do some arithmetic with complex numbers. All right, so here I have two complex numbers. A is going to be 5 minus 3i. B is going to be negative 2 plus 10i. All right, let's add these complex numbers. All right, so to add, so 5 minus 3i plus negative 2 plus 10i is really simple. We're just going to define it to be the sum of the real parts and the sum of, or plus the sum of the imaginary parts. Okay, so this one will be, add the real parts, 5 plus negative 2 will be 3, and then negative 3 plus 10 would be plus 7i. So add the real parts, 5 minus 2 is 3, negative 3 plus 10 is 7i. So really, really simple. And of course you can add in either way. B plus A would be the same thing because addition is commutative. All right, however, subtraction is not commutative. It matters which order you go in. So A minus B would be different than B minus A. So let's do both of those. All right, so A minus B. I have 5 minus 3i minus, and then it's essential that you have the parentheses. Up here it didn't really make any difference, but when you're doing subtraction, it's essential that you have these parentheses. So minus all of B, negative 2 plus 10i. So of course, then this minus will change all these signs in here. So we will have 5 minus 3i plus 2 minus 10i. Then 5 plus 2 would be 7, and negative 3 minus 10 would be minus 13i. Okay, so you have to remember when you subtract, you have to subtract the entire thing, all of it, so it'll change those two sides. So that'll be plus 2, 5 plus 2 is 7, that'll be minus 10, negative 3 minus 10 is negative 13. All right, let's do B minus A. So I have negative 2 plus 10i minus 5 minus 3i. And again, this minus will change all the signs in there. So I will have negative 2 plus 10i plus, so that's plus, so now that'll be minus 5i and plus 3. Of course, I don't really need that plus sign there. All right, so I have negative 2. I got too many i's in there. Oh, that's not 9. All right, so I got negative 2 minus 5. That's negative 7. And I've got 10i plus 3i. That's 13i. That's a horrible looking equal sign. All right, so again, the minus A changed all the signs in A. This became a negative 5 and a plus 3i. So I have negative 5 minus 2, that's negative 7. And I have plus 3 plus 10, that's plus 13i. Notice that A minus B and B minus A are opposites. Notice the signs are exactly opposite. 7, negative 13, plus 13. And that's the way it should be. Because, for instance, if I do 5 minus 3, I get 2. If I do, I forgot what I just said. If I do 5 minus 3, I get 2. If I do 3 minus 5, I get negative 2. All right, so if you subtract in different orders, you should get the opposite. All right, what about A times B? All right, so let's do A times B. Let's multiply complex numbers. Okay, so I have 5 minus 3i times negative 2 plus 10i. All right, so something really neat happens when you multiply complex numbers. Okay, so we're going to define multiplication to be the normal distributive property that you're used to when you multiply two binomials. All right, so 5 times negative 2 will be negative 10. 5 times 10 is plus 50i. Negative 3i times 2 is plus 6i. And negative 3 times 10 is minus 30i squared. So let's double check that. Make sure I wrote them down right. Good. 5 times negative 2, that's negative 10. That's 50i plus 6i minus 30i squared. All right, here we have like terms, so let's combine those. Negative 10 plus 56i minus 30i squared. All right, so here's the neat part now about complex numbers. What is I squared? So remember from the previous lesson, I squared is negative 1. Okay, so I have negative 10 plus 56i minus 30 times negative 1. Right, so this becomes plus 30, and I can combine these two like terms now. So plus 30 minus 10, I'll have 20 plus 56i. All right, so these two expressions are called conjugates. You guys know that already. A plus bi and a minus bi, those are conjugates. These are complex conjugates. Let's see what happens when we multiply two complex conjugates together. So as you all already know, the middle term will cancel away. But then with complex numbers, something else special happens. All right, so let's multiply these. A times a is a squared. A times minus bi will be negative abi plus abi. And just as expected, the middle terms cancel. And then we'll have minus b squared I squared. So I have a squared, middle terms are gone. Remember that I squared is negative 1. So I have negative b squared times negative 1. So I'll end up with a squared plus b squared. Okay, so the middle terms cancel. And notice what happens now. There's no i's left in here anymore. So I'll multiply two complex numbers together, and my answer is now completely real. There's no i's at all. So I've turned two complex numbers into a real number by multiplying them together. All right, so far we've learned how to add, subtract, and multiply complex numbers. Let's divide two complex numbers now. So here I have w equals 5 plus 2i and z equals 4 minus 3i. I want to do w divided by z. Right, so I'll have 5 plus 2i divided by 4 minus 3i. All right, here's how we're going to pull this off. So I'm going to make the denominator into a real number. Okay, so to do that, remember what we just did with conjugates. If I multiply this denominator by its conjugate, it will cause the denominator to be a real number. So I'm going to multiply by the conjugate of 4 minus 3i, which will be 4 plus 3i. Okay, but I can't just do that on the bottom. I have to do the same thing on the top. So 4 plus 3i up here also. So all I'm doing is multiplying by 1, because anything divided by itself is 1. All I've done is multiply by 1. I've not changed anything. But now let's watch what happens. Okay, so down here on the bottom, in the denominator, let's do that first. 4 times 4 is 16. The middle terms cancel. I'll have plus 12i, minus 12i, those cancel. And then I have minus 9i squared. Let's just keep working on the bottom. I'll have 16. Remember, I squared is negative 1. So I have minus 9 times negative 1. So that'll be plus 9, which I'll write it all out. So that'll be plus 9, or like this, minus 9 times negative 1. So that's 16 plus 9, which would be 25. All right, let's do the top. So on the top, I have 20 plus 15i plus 8i. That's plus 23i. And I have 2i times 3i. That's 6i squared. Double check that. That's 20. 15 and 8 is 23 plus 6i squared. All right, again, remember that I squared is -1, so this will be minus 6. So I'll have 20 plus 23i plus 6 times -1. All right, so this will be minus 6. 20 minus 6 is 14. So I will have 14 plus 23i. All right, one last step to do just to make this answer look good. I want it to be written in the form a plus bi. Okay, so this 25 will go with both terms. So my final answer will be 14 over 25 plus 23 over 25i. So my real part is 14 over 25. My imaginary part is 23 over 25.